Okay, we're going to work on some stuff here today, some tutorials. Um, got my old file here. Let's see. Um, where'd it go now here? Boop. So, yesterday I just did whatever I did with Google Gemini and like my own understanding and telling it what I wanted to do. But also telling it to explain what I'm doing as I'm going so I understand. Because again, like circuitry, like this is programming isn't foreign to me, but some quantum concepts are, or the concept of quantum programming. So I'm just trying to wrap my head around it. So, before I get into this tutorial, I'm just going to talk a little bit. I mean, people probably going to care, but I have multiple sclerosis, so that is part of my motivation to maybe cure MS. But I've been left abandoned and isolated, so if nothing else, it's kind of like a which side of me do you want? So I figure if I get good enough, I can either help save the world or I can like destroy everybody's atoms. So be nice to me. Anyway, moving right along here, we got. I want to try this here. So I'm going to go through, I think this is the first tutorial. I've already got Cirq installed, but I want to add this. I don't know what numpy is, so I'm going to add that to my code. Import numpy as np. We'll put it on, we'll put it right here. Import numpy as np. We're going to save that. And I want to see really quick, I'm going to go over here, put what is numpy? So we have an understanding of why we're even. Oh, number pi, numerical pi. Okay. Oh, n dimensional array, and apparently, like, so how Gemini first explained this to me is like visual, not trigonometry, algebra. Once upon a time, I was good at algebra, right? I used to be good at math. I would forget stuff if I didn't have the notes. So like I'd forget stuff in tests, like I'd freeze and I'd forget the, formulas, but if I had something to look at, I was okay. I know that when I went to ITT, the instructor told me that I would be fine taking calculus. I would do okay in calculus, but I might have trouble with the testing. And calculus was heavily test based, and you couldn't have your notes when you were testing. It had to be all memory stuff, and I'd forget stuff. If I had the notes, though, I was, but I had to put a lot into it. I wasn't like I'm not naturally good at math. I'm naturally good at language and certain things and like intuitive stuff. But when I went to school, like I would take my Saturdays. I remember I used to like do my studying, and Briar was really little, so she'd be outside playing, and I'd be kind of watching her. I'd have to stop my studies sometimes to get her to stop playing in the. I had a little pond and stuff. She'd try to stick her little plastic hamburger toys in there and stuff. But back in the day, like I put a lot into it. So I worked 30 hours a week at March of Dimes. I ran my business for Titletown Net at the time, and then also was going to school. Now that was for multimedia, and as it turns out, there might even be a place for that with some of this. So I digress. I'm kind of blah blah blahing when I should be typing here. So let me go back to this. Inquired Cirq. Yeah, okay, so we got all that. We know that that's all good. I just want to add that numpy, but then I want to do this import Cirq Google. So we're going to put that here. I'm just going to make my program bigger here, right? Import Cirq. Was it Cirq.Google? Was Google capitalized? Because everything's case sensitive here. No, it's lowercase and it's an underscore. Cirq Google. Let me go back to this. So we got a Cirq underscore Google. The namings, that's like, you probably keep people busy for hours, like fixing just stupid little things like, oh, I didn't capitalize that there. I forgot. I put an underscore instead of a space. Nope. Well, so we got that print Cirq Google Sycamore, and Sycamore is capitalized, so that's going to take a minute. So when it's saying print Cirq Google, so it's calling. I don't know. I wouldn't say that Cirq Google, but is that a function? I guess that might be a function, but you're importing. I would say it's more of a package that's installed, but You're telling Cirq or Cirq that's connected to Google to print. I think this is like the Sycamore chip, Sycamore device. I'm not sure. That's probably just like their back end, just kind of teach you stuff to make sure it works. So we're going to try this, and it should make my little application that much more interesting if it works. So print, parentheses, oops. We'll go back down to the print section. Print. This one, I don't know. I hope this is a good one. Oh yeah, it has the things. Print, and it was Cirq underscore Google, and then I think Sycamore. I don't know if I spelled that right, but and dot Sycamore, Sycamore, print Cirq underscore Google Sycamore. That looks right. That should be good. So let's save this back over here. Let's give this a save. And let's try to play it and see what happens. Obviously, every time it's going to load the things, that's one thing I'm going to have to get to the bottom of eventually, is why the libraries aren't installed in the place that they're supposed to be. And no module named Cirq Google. Well, there will be in a minute, unless I type something wrong. Let me go back to this. Oh, yep, that was it. That's what I did wrong. It's installed. Let me see what I was just saying. Like those capital letters will get you every time. I capitalized this here and didn't capitalize it. You know how it's gonna go. So it's not there. That one's good. That one's not capitalized. Where do I have the capital? Right here. Whoop. Save that. So we'll see what happens. Of course, we know if it says that it still doesn't work, I obviously know how to install it. Like I just add it to that line of other things, that the Python packages that it's installing. Dun dun dun. Oh hey, look at there, it worked. Look at that. So there's my initial code where it's got the little. It almost looks like a molecule, right? And I think that's part of like what you can do with quantum programming. But there's the grid. That's like the Sycamore chip there, and then there's my code from the other day with the ringing the bell. Is what you call it. But it's like a quantum entanglement code experiment. So there we go. And then, so this is what I'm really trying to like. This is going to be part of my main focus for a while. I might be a little bit slower than some people learning this, but not, because I've already got kind of a head start, so we'll see how it goes. But in Cirq, circuits are represented by a circuit object, and I've already done some stuff. So if I go back to this here, where'd it go? The code. Somewhere in here. Here we go. So let me see if I can highlight it. Well, here, this code, I'll just put it up to the top here. This circuit equals circ.circuit, and then that's where I put my two different qubits, the Q Wendy and the Q. Yeah, I should put it back to Q Weary, because actually, no, I'm going to change it up. Actually, I'm just going to leave it as Q Mike E right now, even though he's a dork. And I'm gonna send this to him. Like, you're gonna call me, because I tell you what, I'm gonna obliterate your atoms today if you don't get a hold of me and you don't help me. Um, Anyway, no, seriously. So there's the circuit. So what I'm trying to do, this piece of code right here. So where it goes from circuit and defines the, what did I call it, an object? So I'm calling it a function, but I guess an object would be make sense too, because if it's object oriented programming, right? But created by a circuit object. Conceptually, the circuit is a collection of moment S, of moments. A moment is a collection of an operation that acts the same abstract time slice. The operation is an effect that operates on a specific subset of qubits. The most common type of operation is a gate applied to several qubits, a gate operation. Now, I haven't gotten that far yet, but a qubit of a circuit is it's defined by its operations. You cannot allocate qubits to a circuit. You cannot allocate qubits to a circuit. Okay. So if you look at this thing, it probably just looks like a bunch of gobbledygook, right? The lines, the vertical lines that are going across, not where the blue boxes are sitting, you got to think of it like if you're reading music. For example, if you're trying to read music, like if you're a musician, for example, but there's like a line or whatever, but instead of like musical notes, every instead of pitches, the lines representing like pitches of audio, the lines represent timelines. I think different areas in time, which is why I've got like these different qubits. So the blue boxes. Oh no, I'm sorry, I take that back. The lines represent the qubits. No, the lines represent the moment. So yeah, that is the timeline. The qubit, so what I don't understand, this is what I don't understand. So the operation, I guess the blocks are the operation, that would be the entire circuit. So that might be the blue chunks must be like, for example, a quantum entanglement. See, and I'm not entirely sure, so don't take this as a tutorial. Take this as I'm learning and trying to inspire other people to learn. If I can do this with a broken brain, people can at least get started on it. And again, a lot of the people that I know from politics are pretty clever, but there's one that's like especially clever, and he might have extra reason to like be interested in this, and he's definitely smart enough to understand it, and that's part of my motivation. All I gotta say is, in the event that I guess maybe he's a former friend, but once he realizes what's going on, all I gotta say is, in the event that he starts doing some of this and he learns how to like save the world and he saves his wife, that he can't forget to save me if I don't figure this out first. That's very important. So yeah, so there's like, um, but that's what I want to try to really grasp. So I got to try to find a video, I think, that really helps me visualize this, because I mean the chart helps, but when the lines are both, oh, moment, it's like a bunch. Okay, so qubit is like a slice, it's like a particle in time. So those lines are like the timelines. I know a qubit is represented by a waveform, so I guess the qubit would be, I don't know what that would be. Was it left to right? The horizontal lines are different qubits. Okay. So, and they're, when you're like writing it, they're represented by squiggle code. So like the double slit experiment. Before, in quantum physics, before a particle takes a position, it's a waveform instead of a, there's another word for it. See, and again, this is just from me being a nerd and being curious about stuff. I'm like, hey, I'm halfway there. Oh, living on some Google. Anyway, the moment is a group that operations happen at the same time. A typical way to create a circuit is shown, and we did that. I want to try name qubits. So I think that my thing today is going to be, ooh. So we're going to try, so we're going to do something totally brand new. Instead of define a list of operations, well, I don't know. I kind of like, okay, so I did this to an extent, but I didn't have 3 qubits. I just have 2 qubits, but it's kind of the same concepts. You see it there. I just did a two-part entanglement here. I'll go back down to my first printout here. Before that, so this here where it says the 2 different qubits, so that's showing them on the line, it's visualizing them. Now there's supposed to be applications that really show this. I mean, hopefully, maybe I would like to find something that shows it in like 3D and like really. That should be a thing. So, like somebody needs to make a program to help programmers like really grasp these concepts where it just like comes to life and shows you instead of looking at this chart. But I think I kind of understand this, right? A program to create the following circuit. Oh, oh, wait a minute. Oh, I see. So that's like an exercise. So you do this, a typical way to create a circuit, and you do that, and then it tells you, and there's the H's. H, H, H. Okay. Operations. Okay. It'd be easier if I had somebody really stepping me through this. I mean, I could, right? I could get Gemini going, but I don't know if I'm like really all, ready for any of that today or right now. But we'll see. We'll see how it goes. Um, but yeah, so this is what it's gonna want people to do. You look at this code and you see where it puts it on A, B, C. Oh, okay, I get it. So what I'm gonna do, go back to this here. See, I got too much other junk on here. Is that like a named or is that grid? Named qubit. So let's just start over here. Save, do file, new. Let's do new, get new, new. Console Python file. Yes, please. And oh, I guess it won't let me do any of that. Maybe I can save a copy. I'm going to save this as a backup. Don't forget to when you're rewriting the world, don't forget to back it up first. It's very important. Okay, so now we have a backup copy. And that's probably all we need. So we can make changes to this and it shouldn't make a whole bunch of difference. So I'm going to see. So what we have is named objects. So we're going to make, what does that have? Three qubits. And that has 4 qubits and 2 x's. So that's kind of interesting. It's like algebra. It's like algebra mapped out kind of thing, right? So you got h, x going up there. I don't know what the x does. Okay, so we'll do. There's 4 of them. Wait, no, there's 3 of them. And then we're going to change this so that it's Q0. And we're going to actually get out of here, screenshot. Q0. Q0. Except this is going to be Cirq named qubit. Yep, named qubit. And we'll call this one me, just because we can. And then we'll do Q0, or Q1. And we're going to call this, so this is going to be named qubit. And this one we'll call segment. Why segment? Why not segment? Q. And then we need the third one, so we're going to go Q3. Wait, no, Q2. Sorry, equals. And we'll do the same thing. Cirq named qubit. And then we'll call this one, let's see, Tron 9000. Okay, so that looks right, I think. And then so what we're going to do here, actually, so we made the circuit. Let me go back to this for a second here. Okay, so then the operations, ops equals, this is going to go here. Ops equals so we have Cirq 1 Oh, I see. It puts them in different. That's interesting. A, B, B, C, B. Yeah, but there is 4 of them, but there's not. But there's 1, 2, 3. But there's 4 different spaces and times, so that's kind of interesting. Define a list of operations. Maybe that's what we gotta do. The ops. I don't know if this is gonna work. Ops. Wait. Square brackets. Square bracket. Cirq.h. So we have something like this somewhere in the circuit right there. I see something. Oh. Oh, I see. I see what it's doing. So let's go back to here. Ops equals, and then we gotta do Cirq. H. want that on 0. Actually, it's like crazy. Circuit and circuit. Circ A. I don't know if I'm doing this right. Let's see. Circ A, Circ H, and then so we probably want the name in there. Circ H A. Circ H. There's 2 of them. Circ H. Oh, I see. Okay, Circ H. Oh, where's the comma? All right. Circ H. Segment. Circ H. Segment. Let me look at this here. See, that's what that segment, and then segment. Okay. Oh, it was supposed to be C naught, though. C naught. So that's the entanglement. Segment, is there commas? Segment and tron 9000. Circ H segment bracket. Circ H segment. Segment bracket. I think that's right. That's very good. And create a circuit. So now what we're going to do, or save this quick. Oh, I want to keep that measurement there, I think. Wait a minute. Is there a measure in the code that's coming up here? There isn't. Print circuit. So no, that was wrong. circuit equals I'm gonna just get rid of this for now. We don't need that. We probably need results because we didn't set that. Oh no, that's right, still right. Cirq ops. Okay, wait, I did that wrong though. So now we're back to here. Let's go and look at this. Circuit equals circ.circuit. Jesus, ops. Okay. Circuit equals circ dot circuit ops. Is there any? See, this kind of throws me, and I have to put like semicolons after each line of code, and then we got print circuit n. Print circuit n. No. So how'd that go? Colon back whack n. Colon back whack n. Is that right? Oh, we need quotey quotes. Print circuit, is that? Okay, so we got that should be pretty much good. I mean, there might be some errors because some of the stuff might not be, because we got data result histogram. And I don't know, because we removed some stuff, we might not have results anymore. So I might have to like get rid of some of the code. But let's see what happens with it. Let's see if at least some of it runs. No, because oh, hello. Save and play. And play. Oh, I see it. I see my error. Oh, let's go code. Okay, now let's try it again. See, I was having this problem yesterday. Cirq has no attribute named qubit. I'm trying code from the actual Google site on all this, and I'm getting an error. Module Cirq has no attribute named qubit. What do I do?
It's that capitalization trap again. It's the most common hurdle when moving from the tutorials to your own keyboard. In Python and Cirq, case sensitivity is absolute. If the Google site shows a capital letter, your code must have.
That's what I did. Change this. But that's what it is. Okay, but I did, so what's the issue here? Oh, no, yeah, no, named. Is it gotta be capital named qubit? That's why. Let's go named qubit. Named qubit. So like I was saying, those capital letters will get you every time. And save. And run. Okay, what am I doing wrong? So now what I'm going to do is I'm going to take a picture of my screen to send to Google Gemini here. Two pictures. So what I just did, the error codes that you saw me, whatever, and I'm going to go to Google Gemini, and I'm going to say, what the F? What is this? Done. What now? See, I didn't tell Gemini that I'm kind of doing my own code and doing my own thing, but... Oh, I see what I did. Okay. Oh, right, because I'm using the name, so let's go back. I see what I did. Ah. Oh, okay, okay, okay. So then down here, we actually got to go back, and then should in theory show the names, maybe, but then this is going to be Q0. This will be Q1. This will be Q, Q1 and Q2, and this will be Q2. I think that's right. Oh, of course not, because like typos, they'll get you every time. My spelling's always been bad. My spelling has always been really bad. I know how to spell Cirq. It's gotten even worse with MS, but you know what? That's okay. I just gotta find where did I spell it stupid? Ugh, right here. Circuit. Pachow. Play. Oh, the banana. Yeah, yeah, yeah. Oh, oh. Wait, what? Wait a minute. What happened? Oh, so there's where I get the error because. So you see how it worked, and then because I had code from like what I was working on before, then that part failed, like I said that it might, because there's nothing to connect it. But there it is. But is it? I did not do it right because it doesn't look. It. That looks pretty cool, but it's got to look like that. So I have to understand the concepts. The code works, but not how it's supposed to. Quantum, in a true quantum experiment, I would have probably zapped a few people or molecules or something, including myself, to a parallel dimension. I think that's might be what just happened. But aside from that, there's there's a learning curve to all this. Did, trying to save the world. Oops, I deleted it and I forgot to back it up. But I did back it up, so it's okay. But yeah, I got to figure out what did I do wrong here exactly. So what I'm going to do from here on out, this is probably getting kind of boring for people to watch, right? But I'm going to go ahead. Notice that the circuit has a total of 3 different moments. Oh, wait a minute. Wait a minute. Let me try something really quick. I'm just going to let's see if that does it. Because it was like 3 different moments, and then you start to kind of conceptualize the value error. Hmm. Note the circuit has a total of 3 different moments. Oh! So you got 1 and 2, and 1, 2, and then 1 and 2, and 1, and 3. 0, 1, 2, 3. Wow, that's heavy. So I'm going to P range 4. Define 4-line qubits. Oh. See, I think when it's like I get it, but I don't get it. So brackets, 3 moments in time. Or three different moments. Define 4 qubits. 4 qubits. That's why. So I need a 4th qubit. Q3. Cirq. Named qubit. Eh. Weed. I don't know. It's just whatever. So now we're going to look at this. So this is wrong. We did this wrong, but let's go to here and then we're going to go Cirq, C naught, Q1, Q2, 3. I don't know if that's right, but we're going to see what happens. Sometimes breaking it is, see, obviously that was, I made a mistake, obviously. Forget a comma. Yeah, I guess I did probably. No, I actually just have a space. Oh, yeah, I did forget a comma. Look at that. Comma, 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 chameleon. And? Hot diggity damn, I'm getting closer, except I kind of put them, they're all kind of like, they're not in the right spot, I don't think. Because it's supposed to look like that. And instead, it looks like that. So now I'm going to pee, but at least, at least I broke the world again. If anybody that I care about finds themselves just kind of floating around, they're like don't know where they are, or they're like all of a sudden find themselves like this might be why it's probably not. But yeah, they're not supposed to be all going down. So actually, I'm going to try to fix it. I really have to pee though, but I really want to get this working. So wait a minute. We need number 3. HH. So let's go back to this code. Let's go back to this code. 0, 1, 1, 2. Oh, 0, 3, and 1. Okay, 0, 1, 1, 2, 0, 3, and 1. It's got 0, we got 0, 0, 1, but then this has got to be 0, 0, and then this has got to be 1. Let me go back to this. Oh, okay. We need another one. No, no, we don't. That's right. It's 1. Okay, so I think that's right. I think we might have it. But actually, this has got to be, oops, 1 and 2. I think that's right. We're going to find out. Dun dun dun. Did I fix the world or did I break it again? Uh, it's getting closer, maybe. I think there's like, wait a minute. That's still not right, so I think I kind of. Wait, I. Almost. So obviously. Or did I do that one? Maybe I just did that. Wait a minute. Belt back. 2 up on top, 1 up on the bottom. Actually, so not quite. I probably broke the world again. So I still got to figure some stuff out. I got to understand this, and I will. And tinkering and learning, trial and error, that's half the battle. So now I'm going to end this video. I'm going to go to the bathroom, but at some point I will be back to try to do more stuff. I hope people enjoyed this and maybe learned something. I don't know if it was entertaining, but maybe it was at least fascinating. It's kind of almost one of those things you can listen to in the background. Or like people could probably even fall asleep to it and then they just wake up and magically know stuff. But yeah. Anyway, hope you have a beautiful, blessed Sunday. Peace, love, light, and kittens.